All right, we are in Chapter 8, Lesson 1, Graphing Linear Equations. So our objective for today is to learn to identify and graph linear equations. So we're going to do two things in this lesson. We're going to identify and we're going to graph linear equations. So there's this word linear equations. Linear equations. What exactly does linear equations mean? Well, I want to talk about the identifying piece of it. And I'm just going to kind of give you some math street smarts. And it's very easy to be able to identify a linear equation just by looking at it. Usually what you need, you need a regular y and a regular x, something like this, okay? This would be a linear equation. Linear equation means a line, okay? It's going to be a straight line. It can be all different types of ways, but it's a straight line. Now, when I say regular x and regular y, what I mean is that there's nothing there. When there's nothing there, that means it has an exponent of 1. Here and also here, there's nothing here, which means there is an exponent of 1, but nobody ever writes equations like that. They just write it as y equals 2x plus 3, and it's understood that this is just an x with an exponent 1 and a y with an exponent of 1. So these are linear. These are linear, okay? Some things that are not linear would be something like this. Y equals 4x squared. Now, y does not have an exponent, which means there's a 1 there, but x has an exponent of 2. So this is not linear. Whenever you have something that has a x that is squared, it actually has this type of U face. It's either a happy face if you put 2 eyes on it, or it could be a frowny face if it was something like this. Negative 4x squared. It would just be frowny. It would be that. They're called parabolas. Yeah. So also this would be something that's not linear. If you had a 1/3 x cubed, well, here it's a regular y, but this is an x to the 3rd power, which actually ends up being some type of picture like this, which you'll learn about one day. Or something else that's not linear would be a square root of x. Now that's something that's just kind of looks like that. But notice it's not a regular x, it's actually a square root. The cool thing about square roots is they can actually be written as an exponent too, but it's in a fraction in the exponent. So that's nonlinear as well. Also, if you had something like this, 1 over x, like that, this is a regular, has a 1, the y has a 1 in the exponent, and you think that this is a 1, but actually the x is in the denominator, the bottom part of the fraction. So you'll learn about this later in chapter 3. This is actually, even though this has an exponent of 1, it's the same thing as x to the negative 1 power. So here, the exponent is actually negative, and those will be fun things to learn about. Now the graph of this, it has a picture as well, and it kind of looks like this. It's called a hyperbola. These are not things that you will learn in this class, but these are things that I'll talk about just so you have some type of math street smarts. I can just look at an equation, and if I know it has an x squared in it, it's going to be a parabola. If it's a cube, x cubed, it's going to look like that. If it's a square root, it's going to look like that. And if the x is in the denominator, it's going to be some formation of a hyperbola. Look something like that. All right, let's get back to linear equations because that's what we're talking about. So some other linear equations could look something like this. 4x plus 2y equals 2. This is a regular x, this is a regular y. Over here, the y is on one side of the equation and the x is on the other, but it is okay for them to both be on the same side, and it is still a straight line. It is linear. We could also have something like this, 1/2, negative 1/2 x equals y plus 3. This is a regular x. There's a 1 in the exponent here, and there's an imaginary 1 in the exponent. So this is a line as well. So you can have some math street smarts without doing the calculations, just being able to look at it and being like, okay, I know that this is linear, and I know that these are not linear. Some other linear ones that are a little fun you'll get into is something like this, y equals 3. And it's like, y equals 3. Well, where's the x? Well, something like this, y equals 3, if I was to draw a little coordinate plane right here, this is very, very small. This is actually just a, when y is equal to 3, let's imagine this is -1, -2, -3, right? This is when y is 3. Y is 3 all the time here. Y is always 3. So y equals 3 is actually just a horizontal line. Horizontal line. Hopefully you can read that. It's kind of small. And another, well, if we can do y equals 3, then what would be x equals 3? Or x equals, let's call it 2. Well, if we make a little graph of that, anything that's like x equals 2 would be, well, this is when x equals 1, this is when x equals 2. And I kind of just like, it helps remember where the hash marks are. You see these hash marks, and if I just extend this out, this is always where x equals 2. And so x equals 2 is actually a vertical line. So those are all the types of linear. You have a regular x, regular y, or sometimes if you just have y equaling a number, that's going to be a horizontal line, or if you just have x equaling a number, that's going to be a vertical line. Okay, that's just a little bit with the Math Street smarts of linear equations. Linear equations, not linear. Okay, now let's talk some more about linear equations. It says a linear equation is an equation whose solutions fall on a line on the coordinate plane. Okay, so this is the coordinate plane right here, and the solutions fall on the line. So we have a line, and the solutions, they fall on this. So any type of points that fall on this line are solutions to the equation. Okay, so it says all solutions of a particular linear equation fall on the line, and all the points on the line are solutions of the equation. So if I had a point over here, not a solution. Point here, solution. Point here, not a solution. Point here, solution. Any points along this line are going to be solutions. All right, let's go ahead and look at what that might look like. I'm just going to go ahead and draw a line here. Okay. Sorry, I'm kind of slow. Let's see. Trying to get a good one here. Okay, I'm going to go with this line right here. This is going to be a line. I'm just drawing a line here. And it goes all the way out here. Goes on and on and on forever. Lines always go on and on forever in both directions. Okay, you guys can all see that. Now, any point on this line would be a solution. Okay? But what I'm going to look at is I'm going to look at where this line meets an intersection, like right here. You see how there are these little black lines, and it's like this grid? Well, right here, this line goes directly in the middle of that grid. Do you see that? Whereas right here, it doesn't. The line's going through the middle of the grid. But right here, there's this black line and this black line, and our line is intersecting all on the spot. So that's an intersection, which means it's solution. Also, here's one right here. Right here. Here's one right here. And also here's another one right here. I'm going to say this is one here. Well, I don't know. That kind of looks like one, but it's not really. And, well, let's just stay with these ones. Don't think about that one. Okay, so okay, so what I see here is with this, it says if an equation is linear, a constant change in the x value corresponds to a constant change in the y value. The graph shows an example where each time the x value increases by 3 and the y value increases by 2. And if you see here, here's this little line, and here points upon that line. These points are solutions, okay? And what you see is that if you're at 1, 2, you can go over 3 units, 1, 2, 3, and up 2, 1, 2. And then you're at another solution on the point, on the line. And then over here, you can go over 1, 2, 3, and then up to 1, 2. And so this is it says if an equation is linear, a constant change in the x value. So this is a constant change. The x is increasing by 3 and then increasing by 3 again. Corresponds to a constant change in the y value. So it's a constant change of up to and up to there. So this graph shows an example where each time the x value increases by 3 and the y value increases by 2. Each one of these solutions I could make into an x and y table like this. And you can see how these solutions are ordered pairs. Well, this is my x, this is my y, this is my x, this is my y, this is my x, this is my y. So my x is 1, my y is 2. That's a point. My x is 4, and my y is 4. My x is 7, and my y is 6. And what you'll be doing in a couple different problems is you'll look at the relationship. You'll be like, okay, what's happening between these numbers? Well, from between 1 and 3, what's happening is you're basically you're adding 3 to it, okay? And then over here, what we're doing is we're adding another 3. So the change in the x's is constant. That's what it's talking about here. It's a constant change in the x value. Well, let's look at the y's. From 2 to 4, what's going? Well, you're going 2 plus 2, and that's how you're getting 4. So the y is changing by plus 2, and the 4 plus 2 is 6, and you're doing it again. And so the y value is also changing by 2 each time. Now what you'll learn is that this is actually very, very close to what's called a slope, and you will learn about that later, but not today. So let's go to our line, and we're going to start here at this point here. And what we're going to do is we are going to start here, and we're going to say, okay, what happens? How many do we have to go over for our x? Well, we have to go over 1, 2 for the x, 1, 2, and then what do we do for our y to get to this next point? 1, 2, 3. Okay, so we went plus 2 for the x, and then plus 3 for the y. What about from this point to this point? How many do we have to go over for the x part? Well, if we look at it, we need to go over 1, 2, and then for the y part, we need to go up 1, 2, 3, and that's how we get to our next solution. So this again is 2 and then plus 3. Now, if we remember, these are ordered pairs. This is 0, 1, and this is, what is this? 1, 2. This is 2, 1, 2, 3, 4. And this one is 1, 2, 3, 4. And then we go up 1, 2, 3, 4, 5, 6, 7. So these 3 points right here are actually solutions. We can write them as a table like this, x, y. We could write 0, 1, 2, 4, and 4, 7. All right? And if we look at the relationship between that, how do we go from 0 to 2? Well, we add 2. And how do we get from 2 to 4? Well, we add 2 again. So this is a constant change. Constant means it's the same thing. It's changing by 2 units each time with the x coordinate. Well, how is it changing with the y? And you could see that. It's changing by 2 and 2. How is it changing with the y? Well, 1 plus 3 is 4, and 4 plus 3 is 7. So it is a constant change with the y as well. And in some of the other problems you'll be doing, it will be the same thing, but the graph will look horizontal instead of vertical like this. And it would just be the same thing. X is 0 when y is 1. And x is 2 when y is 4. And x is 4 when y is 7.